titration curves or pH curves, there are basically three basic graphs. The first one is for weak acid and strong base. The weak acid is CH3COOH, the ethanoic acid. The strong base is NaOH. In titration, basically what happens is that there is a conical flask in which we take the acid, so there is a fixed amount of the acid, and then in the burette there is an excess of NaOH which is added drop by drop to the conical flask, and when the molar ratio of the acid and base is satisfied, then at that point the pH is, that's the end point of the pH, right? Over there the pH should be 7, right? So now over here the first thing to note is that the moles of ethanoic acid are 25 times 0.1 upon 1000, right? And the molar ratio, if we make the neutralization equation of these two, will have a ratio of 1:1 for ethanoic acid and sodium hydroxide. So that means that the moles of CH3COOH, and when the moles of ethanoic acid and sodium hydroxide are equal, at that time the pH should be 7 because it will be neutralized. So that means that when the volume of NaOH is 25 centimeter cube, then the pH will be 7. So this is the volume of the base, so that means that at 25 centimeter cube will have a vertical line, right? So I'll extend a small line from 25. Then this is pH 7. So the details of titration curves aren't in syllabus or AS, it's just the basic shape. So now over here there's a weak acid, right? So the weak acid, pH of a weak acid is about 2 or 3. So the graph starts at, let's say, 2. Right. Then in the vertical portion, when we have a weak acid, we'll have 1 unit below pH 7. So it's till 6, and then for a strong base it will be 3 units above pH 7. So that means till 7 plus 3 is 10, till 10. This will be the vertical section. Then the graph, there is a strong base, right? So a strong base has a pH of 13 or 14. So we'll end our graph at pH 13, let's say. Right. So the graph starts at 2. It hits the vertical portion, and then from the top of the vertical portion it goes till pH 13. So this was the graph for a weak acid and a strong base. This is the strong acid and weak base. So again over here there is HCl and ammonium hydroxide. So the molar ratio again over here is 1:1. Right, so we'll need 25 cm cube of ammonium hydroxide to neutralize the HCl completely. So the end point will again be on 25 cm cube. Right. This is pH 7. Now it's a strong acid, so pH is approximately 1. We'll start at 1. Then because it's a strong acid, so the vertical line will be 3 units below the pH 7 line, right? So it will be 7 minus 3, that is from 4. It will start at 4, and it's a weak base, so it will be 1 unit above the pH 7 line, so that means till 8. Then it's a weak base, so the pH is approximately 11. So the graph will end at 11. Starting at 1, hits the vertical, and then from the top of the vertical till 11. So this is the titration curve for a strong acid and a weak base. One is a strong acid and a strong base. So now over here, again the molar ratio will be 1:1 for HCl and NaOH. So we'll need 25 cm cube of NaOH to neutralize the HCl completely. It's a strong acid, so pH starts at 1. It's a strong base, so the final pH will be 13 approximately. It's a strong acid, so the vertical line will be 3 units below the pH 7 line, and it's a strong base, so 3 units above the pH 7 line. The graph will be like this. Also, one more thing, we can call this line, this basically as the volume of endpoint. That is where the solution or the mixture is neutralized. Only one past paper question on titration curves yet, that is of Feb-March 2022. So this is the question. They've given that there's 0.1 mole of NaOH, right, and 25 cm cube of 0.1 mole per dm cube HBr. HBr is a strong acid, NaOH is a strong base, right? So that means that the first graph will be of a strong acid with a strong base. That is the third graph that we did. Now again, HBr and NaOH are in the molar ratio of 1:1 in the neutralization equation. So that means that 25 cm cube of NaOH will be needed to neutralize the HBr. So I'll draw the vertical line at 25. And the pH 7 line. Now it's a strong base, so starts at 1. It's a strong acid, so starts at 1. Strong base, so ends at 13. Right? And it's a strong acid, so 3 units below, that is still 4, and 3 units above for the strong base, that is still 10. So it starts at 1 and then it ends at 14. So this will be the first. Second part, again a strong acid and a weak base. So it's a strong acid and a weak base, the second graph that we did, the second example that we did. So again over here, molar ratio NH3 when it's dissolved will dissociate into NH4 plus and OH negative ions, right? So the molar ratio will again be 1:1, so 25 cm cube of NH3 is required to neutralize HBr completely. So vertical line at 25 cm cube, pH 7 line. Now it's a strong acid, so starts at pH 1. It's a weak base, so ends at pH 11. Then it's a strong acid, so 3 units below the vertical line, below the pH 7 line, that is still 4, and it's a weak base, so 1 unit above that is still 8. So it starts at 1, touches the vertical, from the vertical goes to pH 11. This is the second graph.